Hello, all you Druids out there. Welcome to Imply's virtual launch event for the first ever milestone for Project Shapeshift. I'm your host, Rachel Podreski, and I have the honor of leading our community and developer relations program here at Imply. Since the first commit nearly 10 years ago, Apache Druid has seen tremendous adoption from developers at thousands of leading companies. Developers who are, as we like to call them, the new heroes of analytics. As every company becomes a software business, building analytic applications has become vital to delivering amazing products and experiences. And developers, like many of you, have turned to Druid as the database of choice for these apps. So, with a name inspired by lore around the Druids, we announced Project Shapeshift, a 12-month initiative to tackle the toughest problems that developers have with building analytic applications. And today, as promised, we're going to show you the first of these shape-shifting spells we have built for Druid with two major announcements. And I know you're excited, and I'm excited, but before we dive into the news, we have a very special guest. I'd like to invite Harini Rajendran from Confluent to join me for a few minutes to share how she and her team have built analytic applications using Apache Druid. Hey Harini, thank you so much for joining me today.
Hey Rachel, it's good to be here.
So can you tell us a little bit about yourself?
Sure. So I'm with Confluent for about 2 years now. I'm one of the backend engineers at Confluent. So I've been in the tech industry for about 7+ years, mainly working on building big data pipelines.
Well, it's awesome to have you. Do you mind telling us a little bit about what Confluent is doing with Druid?
Sure. So at Confluent, we provide a lot of cloud services using our cloud native Kafka and an ecosystem that we have built around Kafka. So our customers actually run their workload in our cloud infrastructure. So it's very important for us to provide them with fine-grained operational visibility into the workload that they run in our cloud. So that's where Druid comes into picture. All of our cloud services actually send metrics which are stored in Druid, and we expose a subset of these metrics to our customers to provide the operational visibility that they need. And we also use Druid for a few internal use cases. For example, our cloud billing is actually based on the metrics that we stored in Druid. And also we use Druid for internal debugging purposes by many engineering teams within Confluent.
Oh, that's really cool. So it sounds like Druid is the database that is used to power a number of different, both internal and external analytic applications for Confluent.
That's right, yeah.
So what was it about Apache Druid that got you initially interested in it?
Yeah. So before Druid, we were using another system in our big data pipeline, but that system wasn't able to scale above a certain level. Like it wasn't able to handle the high cardinality metrics, especially at the volume of data that we had at that time. So when we set out in search for a better technology, some of the things that we had in mind was the next tech that we are picking should easily be able to handle like 100x of the data volume and the query load. It should have like inherent time series support, and it should be capable of providing sub-second query latencies even on high cardinality metrics. So Druid naturally checked all of these boxes. And on top of that, Druid also has this native Kafka integration out of the box. And that is one of the big advantages, right? Like we don't even need any sort of connector or anything to make Apache and Apache Kafka and Druid work together. It just works out of the box, and there's a readily available integration in Druid to work with Kafka. So that's another big advantage too. So yeah, it we have been using it for quite some time now and are really happy with it. And I would also say that we run one of the largest Druid clusters, and so far it has served us well. We have been seeing great performance using Druid.
Well, it's amazing because you guys are fantastic members of the larger Druid community, and I certainly appreciate all your work, and I appreciate you coming to talk to me today. Thank you so much.
Thanks, Rachel. It was nice talking to you.
So, with developers like Harini at the center of our universe here at Imply, we are on a mission to make it easier to build these modern analytic applications. With that, I'd like to hand it over to Gian Merlino, our CTO and co-founder of Imply and the PMC chair for Apache Druid. Take it away, Gian.
All right, thanks, Rachel. Hey, everybody, it's great to be here with you today. Over the last 2 years, I've observed some interesting things from Druid users. First, devs want easy. We've already built a cloud product called Imply Cloud, but we wanted to unlock the full potential of the cloud world and look broadly at what a dev needs to do when building an analytical application. Secondly, while developers chose Druid for interactivity and query performance at scale with tons of users, we started noticing a pattern where devs increasingly want to do more with data in Druid, using that same data set for interactivity and also for less interactive workloads. I also noticed that people wanted to do more in ingestion, shift more data processing from query time to ingestion time, and also from outside the database to inside the database. So today, we're making two key announcements that address these two trends that we're seeing. First, the introduction and general availability of Imply Polaris, our cloud database service built from Apache Druid. And second is a private preview of a multi-stage query engine that we intend to contribute to the community later this year. With this news today, we're addressing what developers are looking for the most, ease and flexibility, to give you all the most developer-friendly and capable database for analytics apps. So next, I want to invite Jad, Imply's Chief Product Officer, to take you first through Imply Polaris, our cloud database service.
Hi, everybody. My name is Jad Naus. I'm the Chief Product Officer at Imply. I lead product engineering here, and today I'm going to be talking about a new product we just released, Imply Polaris. Thousands of companies have chosen Apache Druid so far for building analytics applications. Companies like Netflix, Lyft, Twitch, Charter, all use Druid to ensure the best experience for their users through performance monitoring, network monitoring, and others. Others like Ibotta and Visa and Verizon use Druid to monitor and detect fraud and other security breaches. And others like Target and Walmart use Druid to crunch billions of events a day around retail data and deliver excellent omni-channel retail experiences for their customers. And yet others use Druid to build analytics applications for their own customers like Citrix and Forescout that actually generate revenue for them. But let's face it, building analytics applications is really hard. There are many steps to get there. You got to set up infrastructure, and that by itself requires a whole bunch of things that you need to do, like getting the infrastructure, doing the deployment, making sure you have the right sizes. There's a bunch of stuff you need to do around database operations, making sure you get the data into the right format and the right data model, putting it in, make sure that your queries are the right shape, that they're running quickly. And then all the work around integrations that you need to do in order to get the data into a database for your analytics application and then getting it out of the database through a visualization or through a UI. That's why we built Imply Polaris. Today we're announcing its general availability. Polaris is the easiest way for developers to build modern data applications. We built it on top of Druid, so Polaris really delivers the capabilities of a real-time fast database like Druid at scale and at speed without the operational overhead and effort of managing the hardware and the software that's really required to run this database. Polaris is a fully managed database as a service. With Polaris, developers can get all the performance that they want out of Druid without really being experts so that they can focus on what's important, which is building the best analytics applications for their users. Imply Polaris strips away all the complexity that you might have when you're trying to start building your analytics application on the database side. First of all, it's a fully managed cloud service, so you don't need to think about infrastructure or about how you size your database, how you plan it out so that you can roll it out into production. You can get started immediately, and Polaris makes it easy to scale up and down so that you don't have to worry about making an upfront commitment. We've eliminated all the complex knobs that are required to get performance out of a database, and we've built all of the best practices into Polaris itself so that you don't have to go and learn all the details of how to do that. And Polaris uses all these best practices and gives you all that transparency that you need so that you can really focus on building the right data model and constructing the right queries for your applications so that you can get the best performance for your queries. With Polaris, you get a fully integrated experience. So we don't just give you that database as a service, we give you everything that you need to get started quickly. So first, we really thought about how to make it really easy for developers to get started. And that's why we ended up building push-based streaming ingestion. So you can immediately send data out of your applications without having to go and set up connections or figure out additional data infrastructure in order to do streaming. We have a single UI to manage the entire experience. So in the same UI, you go build your database, you set up your tables, you set up your project size and resources that you need. And you also load the data and set up the data model there. And then we give you a visualization engine that allows you to go and build all the UIs that you might need to quickly start getting insights out of your data without actually having to go and start building your analytics application immediately. Just by loading the data into Imply Polaris, you can actually start analyzing it immediately with Polaris itself. And so the way that we thought about Polaris as we were building it is that we really wanted to empower developers to do everything that they want to do themselves without having to deal with other people. Because as a developer myself, kind of remembering how I used to go and want to build application, it was a really tough time for me to go and deal with DevOps to get the infrastructure or with IT to set up virtual machines or figure out the connections and the security that's needed. With Polaris, you can get started very easily and very quickly without having to talk to DevOps or IT to procure all the infrastructure. It's easy to just sign up and get started in seconds. And then as your project scales up, you can start thinking about other pieces, and we've made sure that all that is handled for you. So as you figure out what your project needs look like from an infrastructure perspective or from a resources perspective, you can scale up and down with zero downtime and really no management on the back end. And as we continuously improve Polaris itself, we'll roll out all these improvements behind the scenes for you, so you don't have to worry about things like log4j vulnerabilities or worry about upgrading your service over the weekend. We'll do that for you. Polaris really handles all the hard parts of managing a database. We do all the work around security, availability, disaster recovery so that you don't have to think about these. These are all capabilities that are built in, so you don't have to worry about, say, what happens when a node fails or whether data is replicated enough so that if there's a disaster, you can come back up from that. Polaris deals with all the security needs for an analytics application. We encrypt data in motion and at rest, and we use native cloud services like S3 to keep data backed up and ensure reliability. All this while making sure that we tackle any security vulnerabilities that come up transparently behind the scenes for you, so you don't have to worry about whether or not we've applied the latest patch and kept our service secure. One of the biggest asks that we always hear from our customers is that they want to scale up and down ingestion. Data ingestion is often spiky, whether it's being done through batch or through streaming. And our customers always ask, can we make autoscaling ingestion a key capability, let's say in Apache Druid? And it turns out that, while we could make the software do that, the real difficulty is managing the resources and the hardware and infrastructure behind the scenes to actually make it work well. And so with Polaris, we bundled all the software and the management and the capabilities that are needed to make that easy. And we make it so that developers don't really have to tune any parameters to get the performance and to get that autoscaling. We make efficient use of the resources for you, so you don't have to pay for nodes that are not actually getting used or for hardware that is just spun up and not being used. All this while making sure that the performance of ingestion is fast so that when you're streaming data, your real time stays real time and your data stays fresh. The other piece around ingestion, as I have alluded to earlier, is that very often to get data out of your infrastructure into a database, you have to get the database to pull out of that infrastructure. In order to do that, you have to do things like set up connections or open a VPN or make a VPC peering setup or any of these really heavyweight things so that you can have one piece of infrastructure reach out into another piece of infrastructure and get the data. With Polaris, we wanted to make it really easy for these developers who are building analytics applications to just send their data into Polaris. And so what we've done is we've turned streaming ingestion into a simple REST push API where developers can easily send events from their applications directly to Imply. And so you don't need to go and punch through firewalls or provide access to internal infrastructure, share credentials with us or any of that. You can just immediately send the data to us, and you don't have to go and talk to IT to let you do that or talk to DevOps to do that. And you can start really small and just start with a small amount of data that you're going to send. And with autoscaling, you don't have to pay for what you don't use. And then as you scale up, we've built in the reliability of Confluent Cloud behind the scenes for our streaming ingestion service, so you don't have to worry about your data getting lost. And so with our database optimization capabilities that we've built out with Polaris, we also eliminate the tuning and guesswork that's needed to go along with that tuning that you might need to learn or figure out as you are building a database application. We automatically configure Druid for your use case using our expertise, so you don't have to become a Druid expert. And Polaris provides all the performance monitoring tools that you're going to need around your queries and your application as it's interacting with our database, so that you can optimize the data model, the layout of how the data actually sits in Polaris, and the queries that you're executing, so that your queries are really built the right way. We have an easy-to-use guided UI so that when you get started, you don't actually have to be an expert at setting up Druid in order to get the data in or in order to get that performance. As you scale up, as you want to go and get more and better performance with larger data, we'll handhold developers along the way to make sure that you're able to get the right performance at the right cost. Along with that performance monitoring that's built in, we are looking at the health of your database and the queries that are coming in from Polaris. What I'm showing here is just an example of the dashboards that we have in Polaris. Here we're looking at a dashboard that's showing us the performance of the queries that are getting executed. And with Polaris, you can go from a dashboard that looks like this, that is pretty high level, into a detailed view of the metrics that are associated with the queries that you're executing, so you can really drill down into the root causes for slowness in your queries so that you can ultimately deliver a really great user experience for your users. One of the things that we really wanted with Polaris, like I said before, is to make it so that people can get value as quickly as possible with Polaris, to really get started and get to insights as quickly as possible. So what we've done is we've integrated a powerful visualization engine inside Polaris that really was built from the ground up to work really well with Druid. And the fact that it does queries, kind of slice and dice queries, aggregations, and breakdowns really quickly. And this allows us to provide ad hoc analytics, interactive ad hoc analytics for workflows that are more focused on diagnostics or on exploratory analytics to try to answer questions about why certain things are happening. With Polaris, as soon as you load your data into Polaris, you have that ability to start slicing and dicing the data and immediately start building dashboards for users that explain what's happening or to enable them to understand what's going on. With Polaris and with this visualization dashboard, you can this dashboarding tool, you can up-level your entire org and empower them to start making critical decisions using data in motion. And as I've kind of iterated multiple times, really, we've tried to make Polaris a one-stop shop for everything that a developer would need to build an analytics experience. We have an integrated SQL IDE for writing and testing your queries when you load your data, to iterate on the shape of your data model or to iterate on your queries. We have a visualization engine that allows you to immediately start getting insights from your data without having to go and build an application in the first place. We built in infrastructure management so that it can scale up to your needs without having to go and manage hardware or procure hardware or talk to IT and DevOps. We built push ingestion so that you can get started with no friction in terms of getting connections and getting access and security, sign-offs and so on. And we built in usage metering and monitoring so that you understand how your usage is progressing, and so you can keep track of your costs. And finally, we have a curated performance monitoring dashboards and really performance workflows that will help you get to performance for the queries that you need for your application. Polaris is now available. You can get started for free with a 30-day trial, no credit card needed, and you only pay for what you use afterwards. You can get started small, and then as you figure out what you need, you can scale up or down as you need. We've built Polaris to really empower developers to build analytics applications easily. You can start in seconds without having to deal with DevOps or IT or infrastructure or figuring out security and connections and VPC peering and so on. And Polaris is really secure by default and scales to your needs so that you don't have to worry about starting with something that locks you in terms of your future optionality. It's highly available with automated replication and backup, so you have peace of mind in terms of the data that you're sending and the fact that your application will stay up. And finally, a powerful UI to deliver the insights that you need without even writing a single line of code. With Polaris now, Imply has a full portfolio of services ranging from fully self-managed software deployment models like Imply Enterprise, where we allow our users to deploy Imply behind the firewall completely isolated, to Imply Enterprise Hybrid that runs inside a customer's AWS VPC, but managed externally by Imply running in our infrastructure. And then Polaris takes this the whole way into a fully managed infrastructure, fully managed deployment, where we take that management completely off your hands so you can really focus on building applications. I'll now hand it over to Gabriel to show us a very quick demo of Polaris.
Hello everyone, my name is Gabriel Tavridis and I'm a product manager here at Imply, responsible for Imply Polaris. And today I'm very excited to be here with you and give you a demo of Imply Polaris. Now in this demo, I'm going to show you how you can build a modern analytics app in less than 10 minutes. And to do that, I'm going to cover 4 key areas. First, I'm going to show you how easy it is to get started with Polaris. Second, I'll show you how you can create a table and stream data into Polaris in real time. And third, I'm going to show you how you can use Polaris's analytics capabilities to extract valuable insights. Closing, I'll show you how, as a developer, you can monitor the performance of your users' queries so that they always meet your SLAs. For context, the dataset we're going to use in this demo is from a global brand which is selling office furniture, supplies, and tech equipment and generate thousands of order transactions a day. Let's jump right in. The first piece we're going to cover is around getting started with Polaris. Now, as Jad mentioned, this is extremely simple. In less than 5 minutes, you can be up and running with Imply Polaris. To do this, you go to the imply.io website, you click on Get Started for Free, you land on the sign up page, you provide your first name, last name, email address, you choose a password, and then you also select an organization name, which is going to be the instance that you're going to be using to access Imply Polaris. You click sign up, and then we take care of the rest. Imply Polaris is a fully managed cloud database as a service, and to get started with it, you don't need to set up any infrastructure, you don't need to do any sizing, you don't need to talk to any DevOps team, you're basically free to go. Now, as soon as you go through the motions, we're going to send you a verification email, you're going to send your welcome email, you're going to land on the login screen of your organization. Now, as you can see from my screen, there are 2 ways in which you can authenticate with Imply Polaris. You can either use the email and password that you've created, or you can also configure your identity provider of choice and sign in with single sign-on. Now, in this particular case, I have configured single sign-on for my organization, so I'm going to click on SSO. Now we're going to transition over to the, once you basically sign in, you'll land onto the Imply Polaris homepage. Now, this is the place where it gives you access to everything you want to do within Imply Polaris. You can access all of your data cubes and your dashboards. You can access all of your tables that contain your data. You can access performance monitoring and user query monitoring. You can scale up and down, and you can also access user management for role-based access control, as well as usage and billing. Now, for the second part of the demo, we said we want to show you how you can, we need to find a way to bring data into Polaris. Now, to do that, we go into the table section, and in order to get data in, there are, you can either kind of go ahead and create a brand new table, but for the purposes of this demo, I have already created a table that contains like all of the columns that we need. Now, what you see here is the schema of my table. Now, I have kind of the following options. I can either click on Edit a Schema, which takes me into a schema editing interface, and I can make a bunch of different changes to my schema. I can choose to change the names of different columns. I can choose to remove some columns and add them back again. I can create like brand new columns, or I can also go a little bit deeper, a little bit kind of further, and I can make changes such as enabling rollups. So, for example, if I know that my data is going to be aggregated, I can turn rollups on, and Polaris immediately recognizes which columns in my table could be used as dimensions, in this particular case, category, city, country, and customer name, as well as which columns could be used as measures. Now, Polaris kind of does that from the get-go, but that doesn't prevent me from, going and making changes to that, such as adding additional dimensions or like removing some of the existing ones based on kind of the needs that I have. Now, for the purposes of this demo, we're not going to aggregate data. We want to have kind of the source data. So I'm going to turn rollups off. So I finalize the changes that I want to do to my schema. I'm going to click Save, and I'm ready to go. Here, the thing that I want to emphasize is that we're kind of doing this via the UI, but all of the Polaris capabilities that you're seeing are also available via an API. Now, we have a table. Next step is how can we get data into this table? Now, with Polaris, there are two ways in which you can do that. You can either click on Add Data, which will trigger a batch ingestion workflow, like your data resides in some file and you want to bring them over and ingest them in. But you can also use push-based streaming. Now, you see this push API endpoint here, which is a publicly facing URL that is exposed per table and allows you to stream data into this table from anywhere in an authenticated manner. Now, to do this, I have put together a very simple script. You see here that I'm selecting I've entered my organization name. I have the publicly facing URL, the push API endpoint, and then I also have all of my authentication parameters. So for context, Imply Polaris is using auth 2.0 for authentication, which means that the only thing you need to do is you can go to API clients, create an API client, and then pull in the information into your script. So I have my table, I have my script. Let's start running that, and immediately we're going to see data flowing into the table. So you see the script is running and data is ingesting. Great. Now I have data in. Now the next step is how can we extract valuable insights out of that? Now let's go back. We're going to go to a Visuals tab. I'm going to create a brand new data cube. I'm going to select the table that I've just created. I'm going to click on Save. And now I'm exposed to a very powerful UI that gives me the ability to slice and dice the information in any way that I want. Let's say, for example, I want to see sales information, and I want to see this by market and by product category. And because the table layout is a bit kind of too detailed for me, I'm going to use one of the very powerful visualizations, and I'm going to make it look like a horizontal bar. And like in less than 5-10 seconds, I'm able to actually have kind of data in and then have like a very powerful visualization that allows me to get a better glimpse of my data and extract valuable insights out of it. I can share this, I can put this in a dashboard, I can share this with colleagues, and I can help kind of spread these insights within my organization. Now, as a developer, though, one of the things that you have users that are actually running queries and extracting kind of insights of it. As a developer, you also care about what performance these users get. And you want to know whether they run into performance bottlenecks, whether you need to go and kind of fix something or make any changes. So in Imply Polaris, we have a monitoring section that exposes you to a number of different capabilities, such as seeing the performance of user queries, seeing the performance of streaming ingestion, as well as a data cube that gives you access to slice and dice the information in any way that you want. So for example, in the user query section, you can answer questions such as, how's performance looking? Is it time for me to scale up and scale down? Do I need to make any changes to the layout of my schema? And a lot more. Great. So at this point, we've seen, quite a few things around Imply Polaris. We've seen how easy it is to get started, how easy it is to create a table and stream data into this table in real time, how you can actually explore the powerful analytics capabilities to slice and dice the information, to extract valuable insights, and then also how you can be on top of your users' performance to ensure that they're not running into any performance bottlenecks. And this actually concludes our demo. Thank you so very much.
Thank you, Gabriel. That was great. Really appreciate it. Next, I'm going to be chatting with Paolo Lucente from NTT. We have with us today Paolo Lucente. He is a network engineer at NTT. Paolo, welcome. I'd love to hear a little bit about you and about your role at NTT.
Yes, thank you very much, Jad. And it's remarkable you nailed my surname. It's not everybody that manages to do that. Yes.
I'm told I'm okay with accents.
Yeah. So yeah, I work for NTT, which is the Japanese telecom company, and NTT is a big group, and we are the GIN, the Global IP Network division of NTT, essentially connecting IP transit provider. We are connecting over the internet, companies all over the globe. And I myself, as part of this organization, I am leading the analytics collection, essentially like collecting all the telemetry data and storing them in a secure place, let's say, and then making sure that the data can be explored and actioned upon.
Great. So as you know, we're launching Imply Polaris. You guys have been some of the earliest users of Druid and one of Imply's first customers. I'd love to hear from you a little bit. I know you guys really use Druid pervasively, probably some of our most advanced users with Druid. I'd love to hear from you some of your use cases. What do you guys use Druid for, and how do you use it?
Right. So yeah, we are Druid is an essential part of our, of collecting all our telemetry. Like we are a network operator, and so we drop onto Druid all our SNMP and flow, data. And like our main use case is, to analyze all of this data. So to store it in Druid, and then to how to say to self-service, to allow people to self-service themselves with that unbelievable data exploration tool that is Pivot.
That's great. Maybe you can tell me a little bit, who are your users? Just a smattering.
Yeah, I would say that our user base is very distributed. It's all internal, like so colleagues, I would say. But everybody's spanning from NOC to engineering to operations, and even to our management, right? So that for me voices a lot about how versatile the data exploration part is. And yeah, that's it.
It's awesome. And as I mentioned, Imply Polaris is coming out. If you kind of go back to your earliest days when you first started with Druid and Imply, how would you think about the availability of something like Imply Polaris, a fully managed SaaS offering?
Yeah, that is absolutely great. That is absolutely great. So going back in time, so we started, with on premises, and we are very happy about it, right? So I cannot tell you like that. like I am excited about the SaaS offering because the on-premises is, because there is some problems. Absolutely not. But it is true that a SaaS offering further decreases the amount of, maintenance and things like that requires to, make the cluster working and up to date and everything. So we are absolutely excited. We are not there yet, but this is the year that we will be transitioning from on-premises to your SaaS offering, and we are totally looking forward to that.
That's great. Great, awesome. Well, Paolo, thank you so much for taking the time. Really appreciate it.
Absolutely, my greatest pleasure, and keep up the good work.
All right, take care.
Bye.
Great, thank you so much, Paolo. Next, I'm going to hand it back to Gian.
Thanks, Chad. That was really cool. And now I want to talk about how and why we're adding a multi-stage query engine to Druid. But before I talk about that, I want to talk about the core Druid Query Engine and how that works. So the core Druid Query Engine that we all know and love is really good at fast, high concurrency queries at scale. This engine is famous for being able to do queries over trillions of rows in less than a second at really high concurrency. And the key here is to be really simple. In computers, the less you do, the more you do. So don't do work that doesn't have to be done. We have a very tightly integrated query engine and storage format where we store both the data and indexes on that data to minimize the amount of stuff we need to look at to get a query done. And also very efficient execution through a scatter-gather system. The way the scatter-gather system works is diagrammed here. We have a query server that handles the initial query request from a user, fans out that query to all the data servers. Each data server has some data and indexes on that data. They return their partial results back to the query server. The query server merges those, returns them to the user. This is a structure that works really well for rapid fire queries where most of the work is done on the data server and where the amount of work or the amount of data returned by the data server to the query server is relatively small. Think, for example, of a data set of trillions of rows where you're grouping by country or grouping by city. The number of countries and cities is not very high relative to the size of the overall data set. And in Druid, we have a wide array of query features that fit into this really high performance structure. However, there's some stuff that does not fit super well into this structure. Things like queries with very large result sets, joins of two very large tables, subqueries that are very large and where further processing is needed on that subquery. These are all cases where a lot of data, as it were, escapes out of the data server and needs to be processed in a way that a single query server would struggle to process, and it becomes a bottleneck. So to address that, we're building a multi-stage query engine for Druid. And the multi-stage query engine is intended to hook into existing core query engine routines. So being able to use all that really high performance Druid segment reading code that the core query engine uses. However, instead of sending all the partial results to a single query server, these multi-stage query or servers involved in multi-stage query can exchange data amongst themselves in a shuffle mesh. And then each stage of these queries can be parallelized to run across many data servers at once. On top of this, because these queries are more complex than the core queries, we know we're going to need to add automatic tuning and the ability to scale the system to any size. The first one I want to talk about is reports with long-running heavyweight queries. This is the original inspiration for building the multi-stage engine in the first place. So many reports need long-running queries. Reporting queries also tend to be more complex than interactive queries involving subqueries, joins, things of that nature. Long-running queries also require an asynchronous query API. The core Druid Query Engine uses a synchronous query API designed for these sub-second queries, or even queries that take a few seconds. But this synchronous query API, where you're waiting for the response, is not really a good choice for a reporting query that may take dozens of seconds or even minutes to run. And because these queries take longer to run, we're also building the engine to support progress information on long-running queries to keep you informed as a query runs, a feature that wasn't really necessary when most queries complete in less than a second, but is really important for a query that could take a long time. Another really interesting thing we can do is rethink ingestion. So a lot of SQL databases out there support the ability to create a table from a select statement, and we're adding that capability to Druid. So this is really awesome because in the classic Druid world, you use JSON specs in order to do ingestion, and this JSON language is honestly a little bit idiosyncratic. With the ability to do ingestion through SQL, you can use common SQL statements to pull data from external sources, ingest that directly into Druid. The nice thing here is that the full power of the query engine is available as part of ingestion. And by being able to do more stuff in the database as data is coming in, there's less of a need for data preparation before data gets into the database. Of course, the ability to insert data from external data sources into Druid tables suggests that there is a way to get external data into the query engine. And that is true. So with the multi-stage query engine, we're building in the ability to load external data and query external data. This actually can be used to query external data directly, although I don't think that will be a primary use case for Druid. A system designed for that would be, I think, a better choice. But I do expect that this functionality will be useful for combining Druid data with external data. For example, doing a query time join of a Druid table with an external table. Another really cool one is in-database data transformation. This is actually something that's already possible today in Druid. Again, using those JSON specs, although there's two issues. One is those JSON specs, as with ingestion, can be annoying to write. And the second one is that the functionality available in the JSON specs is limited compared to what's available at query time. So the idea here is by feeding the results of a multi-stage query into an insert command, into an insert operator that generates Druid tables, we're able to get the full power of the query engine and use that to do transformation of data in the database. This is going to be really useful for things like creating summary tables, creating aggregated tables, creating filtered tables, and even saving the results of any query to a table for later usage. Finally, I want to talk about something that I think is going to be really cool. So some databases out there separate compute and storage, and some databases aggregate compute and storage. In Druid, we actually have a unique approach that sits somewhere in between. We do have a separated deep storage, is what we call it, where we store all of the data, but we also prefetch everything from that deep storage onto data servers before it's queried. And so you never, with the core Druid engine, it's never required to hit deep storage to query data. This is part of how we get that really amazing performance. You never have to wait for data to be populated in that cache before it's queried. With the multi-stage query engine, given that that's designed for less interactive workloads, we saw an interesting opportunity there to still have that cache, but to, rather than prefetching data into that cache, to populate it more on demand. And the idea here is that with an on-demand populated cache, as opposed to a prefetch cache, that's a sort of moving on the spectrum towards more separated compute and storage. And by giving that option to people using Druid, it's really going to open up the ability to run Druid at very different places on the economic spectrum. So you can choose whether you want to have things be super fast and cache all the time, or maybe you're willing to sacrifice a little bit of performance, reduce the size of the cache a bit, and query more data out of the network. And I think these options are really going to be helpful. So now I want to talk about the availability and rollout plan for this multi-stage query engine. Certain new capabilities that I've talked about today are currently in private preview for Imply customers. And we'll be working with the community to integrate this work into Apache Druid later in the year. In the meantime, if you'd like to participate in the preview that we're running, reach out to us. Otherwise, stay tuned for more news later. And for now, I'd like to hand things over to Vadim, who will demo what's some of these capabilities in this query engine.
Today, I want to show you what is possible using the new Shapeshift query engine. Specifically, I want to focus on reimagining the ease of use of ingesting data into Druid. I will show you how Druid ingestion can now be done using Druid SQL, allowing users to rely on their existing knowledge of SQL, and how it's no longer necessary to tune the ingestion at larger scale. So starting off, right here we have our Druid console that we know and love, and here I have a query loaded. This query is actually all that I need to start ingesting data into Druid. And if you're familiar with SQL, you should be able to get your bearings around. I'm inserting some data into a data source. I'm reading from this extern definition that defines some external data as a logical table, and I'm selecting all the columns. I'm saying that we're just going to have everything go into one time partition. Now I could preview the data, which I actually just did, and I can see what it will look like before I even ingest it, allowing me to iterate. In this case, let's just ingest it real quick. Right here, you see the multi-stage nature of this engine. You see the stages being planned out, just 2 stages for this very simple query. And very importantly, you see progress reports in these progress bars and counters. They allow you to have a good sense of how long is this query taking and how long will this ingestion take before it completes, which is a very nice feedback to have when you're loading up data. So let's just wait for this query to finish. And there it goes. I can see that I inserted this many rows and this data is now available for me to query. Now let's look at another demo. The first demo really focused on the simplest ingestion you can possibly have. In this demo, I want to show you how to do all of the cool stuff you can do in Druid, but using SQL. So here, I'm defining my external data in this little neat tile right here that allows me to collapse it. And I'm saying I want to parse time. I want to floor it to create a query granularity. I want to define some dimensions, which I will then group by on. I want to define a filter, and I want to define some measures. All of these things are expressed using standard SQL. And now I can start this ingestion, and I get all of the features that naturally would probably take me a lot of time reading the Druid documentation to understand how to do now. But I get it all rolled into one SQL statement that pretty much fits on my screen. And again, this query finishes very quickly, and this data is ready to query. Lastly, I want to take us beyond what is currently possible in Druid into something that currently requires you to have another tool, some sort of an ETL tool like Presto or Spark before Druid, and to pre-process your data with that tool. In this case, I'm loading that same data defined by this file on the internet, and I have a lookup table, and I want to actually enrich this data by doing a join. So I'm going to do a join of this table to actually pull out the capital of every country and also the ISO codes, because maybe I want to do a geo visualization. And I can see it's very easy to express that with SQL, and this is now something that is possible in Druid. Running this query again, I can see the new plan being planned out, and I can see that this plan is much more complicated than the one from the first query, because there's a lot more interesting things happening here. But still, I get a good sense of progress, and now this query is complete, and I'm ready to query this data as soon as my segments are loaded. Let's go and query this data just for fun. And there it is. Thank you for tuning in. And now I want to hand over to Rachel to close out the show.
Thank you all for taking the time today to learn more about the first milestone of Project Shapeshift. If you are as excited as we are, be sure to check out imply.io/Project Shapeshift or send us an email at contact@imply.io. Until then, I will see you all in the community. Bye for now.